Well, I hear you thinking now, you're thinking, he's just used another chemical, ammonia. So perhaps I ought to explain where we can get ammonia from if we want to get this naturally. Okay. Well, believe it or not, ammonia can be generated by the distillation of various bits of animals, let's say. Okay? And the sort of classic route for doing this was actually the distillation of antlers. Now, there's a particular type of deer called a hart, and here it is here, the little deer over there. It says the hart. This is from a 17th century book. So if you take the antlers from a hart, or it could have been actually any nails or hair or other sort of animal matter, if you heat this up, it decomposes and it gives out ammonia gas, it gives out carbon dioxide and water, and these all combine together and form ammonium carbonate. Now, we tried this, we heated this up, and what you get out of this, well, they used to call it spirit of hartshorn, because that's what you started from, some hartshorn. In fact, this bottle that I have here says, this is quite an old bottle, it says, best quality hartshorn ammonia. All right, so this was entirely natural-ish, okay, if you think distilling antlers is natural. So we thought, well, this would be really fun to demonstrate this in the lecture theatre, so we tried this. But we soon discovered that it wouldn't be a good idea to do this in the lecture because you get the most horrible, horrible smell when we tried this. In fact, all the students who were working in the lab complained about this, and anyone who walked near the lab said, what was this horrible, horrible smell? It isn't actually the smell of ammonia, it's the smell of sort of burning hair. Well, we got Chris to do this, because Chris is very brave with these sorts of horrible things. Chris took some horse's hair, put it into a flask, as you see here, heated it up, and you get this horrible thick brown oil, really, really disgusting. But keep heating it up, and eventually this white smoke comes over, and that's what you see there, this white smoke. And we collected this, and here it is. It says salt of hartshorn. Well, that's what they used to call this. This is ammonium carbonate. Now, this doesn't really smell like disgusting burnt hair. This smells of ammonia. In fact, ammonium carbonate, which we have here, used to be used as smelling salts. So whenever anyone fainted, they'd have a whiff of this, and this would certainly perk you up, but it's the smell of the ammonia that you detect. Now, I have some ammonia that we can pass round. We've put some ammonium carbonate into this bottle. There's just a little bit in the bottom. Okay, and there's a little hole in the piece of rubber on the top here. So if you push down on the rubber and sniff cautiously, yes, you can detect the ammonia. So I thought you might like to experience ammonia for yourselves. So if we pass this round. So remember, this contains ammonium carbonate. Well, we thought we had to check to make sure that the salt of hartshorn that we got from the distillation really did contain ammonium carbonate. So we had a crystal structure determined for this. And this was done in the department here. So by shining some X-rays onto our crystals here, it revealed the presence of the atoms in the structure. The blue are nitrogen, and they're surrounded by 4 hydrogens. Well, that gives us our ammonia, or ammonium, and the black and the red there make up the carbonate unit. So this is ammonium carbonate. And that actual thing that you're seeing whizzing round there, that really was these crystals that came from the distillation of the hair. The crystals here gave us this structure. In fact, our crystallographer, I think, is somewhere in the audience, John, wherever he is. There he is, right at the back. Yes, he got very, very excited when he ran the structure of the ammonium carbonate here, because he thinks it may actually be a new morphology of the ammonium carbonate and never seen before. And if this is the case, we're going to have to publish this and describe how we made our ammonium carbonate.